In my presentation today, I will be discussing Huntington's disease, the basal ganglia, and the subsequent changes in brain function in these patients and focus on how this impacts their speech. Huntington's disease is also called Huntington's chorea, as we've seen in our textbooks. Chorea means to dance in Greek, and we will talk about the characteristics of chorea later on in this presentation. Huntington's disease is a neurodegenerative disorder, meaning the nerve cells in the brain are dying, they're degenerating, which causes hyperkinetic dysarthria, which is a motor speech disorder that we will discuss later. It is an inherited disease where a mutated gene is passed down. It is incurable as well. The main features include age of onset being in adulthood, usually 40s and 50s. It is progressive and eventually leads to death. In the bottom right corner, I have put a hyperlink there where you can check out Jane's story, and she is someone who is affected by Huntington's disease, and she talks about her life and how she tries to overcome the disease, how she tries to not let it define her. But you can also see some of the signs and symptoms of this disorder manifest in her, so I'd recommend checking that out. So as I mentioned a little bit in the last slide, degeneration of the basal ganglia is what's causing the dysarthria and all these signs and symptoms. So this is the site of the disorder. I looked at several different sources, and most all of them will agree that the degeneration is significantly seen and mostly seen in the striatum, which as we can recall, is the caudate nucleus and the putamen. And whenever this caudate nucleus is degenerated, it's going to lead to hyperkinesia or hyperkinetic dysarthria, because the caudate nucleus aids in verbal fluency, control of speech movements, by inhibiting unwanted movements. I have posted another link on the bottom of this slide here, and it is a blog post from the Huntington Outreach Project for Education at Stanford website. And the author of this blog post, Stephanie Liu, she discusses how the nerve cells die in the striatum in Huntington's disease. Because it's interesting that other nerve cells in the brain aren't really affected. It's mostly the basal ganglia. She talks about how the Huntington protein is present in all cells of the body, throughout the body, because it's important for development. And scientists believe that this protein solely interacts with the brain. And so whenever it's mutated, as in Huntington's disease, there becomes a disruption in the brain, in the interaction between the brain and the nerve cells, leading to cell death. But not much is really known about how and why only certain cells degenerate in Huntington's disease, but we do know the protein that's mutated, and that it's causing significant damage and cell death in the basal ganglia. So I would recommend checking out that link. It was very helpful to me to see how the nerve cells are degenerated in the striatum. Here I've posted a picture of a normal brain and the brain of someone who died with Huntington's disease. And as you can see, in the middle, in the center, is the basal ganglia space, the caudate nucleus, the whole striatum, and how you can see in Huntington's disease how that is severely degenerated, and that's why the space is so big, because those nerve cells have died off because of that mutated gene. But how interesting it is that other parts of the brain are relatively untouched. So it's very intriguing. Reading et al. In one of the articles I read and researched talks about pre-symptomatic brain functions. And she defines this as no manifestations of Huntington's disease, no physical manifestations. So someone who has pre-symptomatic brain functions, they have the gene, but it hasn't progressed into the more physical aspects of Huntington's disease. So in Reading et al.'s study, they used fMRIs to study and compare the activation patterns in people's brains. So they looked at people with Huntington's disease with that gene and a control group. And the ones that had the gene for Huntington's disease noticed impaired attention, planning and memory difficulties, impaired visuospatial abilities, language impairment, and they also found significant abnormality in performance on the Stroop interference test. So these are the beginnings of Huntington's disease, these changes in brain function, which are going to lead to a lot of personality change, irritability, depression, and other sort of psychological symptoms, because the chemistry of the brain is so altered by this degeneration of the basal ganglia. Common symptoms include chorea, which is the most prominent one. It is characterized by dance-like movements, flailing of the arms and the face and the tongue due to involuntary muscle contractions. And you can see how this impacts speech and misarticulation, with the face and the tongue being relatively uncontrollable. Hyperkinetic dysarthria, as we mentioned before, is a motor speech disorder, and it is mainly characterized by hypernasality, involuntary speech movements, strangled pitch, a varied speech rate, and voice stoppages. And again, this is all due to the degeneration of the caudate nucleus, which helps in the forward flow of speech, how it aids in the verbal fluency, control of speech movements by inhibiting unwanted movements. We also see rigidity, dysphagia, swallowing problems, usually leading to aspiration, and oftentimes leading to death, because aspiration is one of the main causes of death in Huntington's disease. We also see personality change, signs of dementia, depression, memory problems, and other sort of psychological symptoms. The main and sole cause of Huntington's disease is a genetic inheritance of that mutated gene that we discussed. So we talked about the Huntington protein and how it is present in the whole body. And so it's when that Huntington protein is mutated that we have the IT15 gene, which is that mutated gene that is causing all the nerve cell death. So if a parent has this gene, there's a 50-50 chance that their offspring is going to inherit it. And if that offspring does inherit it, there's a 100% chance that they're going to develop it, that they're going to express it. But these core symptoms will not develop until later in life. I'm going to briefly discuss assessment and treatment. Assessment usually comes in the form of a holistic approach, so they're going to look at the physical, psychological, psychiatric symptoms, and so they'll look at the chorea, the dysarthria, the depression, all those sort of aspects. They're going to take into consideration the caregiver's needs, and they're going to most often use the Unified Huntington's Disease Rating Scale, which measures the features of Huntington's disease and their progression. It provides a severity. As for treatment, there is no cure and no way to stop its progression. Oftentimes, medications are prescribed to possibly slow down the progression and improve the quality of life. But again, you cannot stop the progression, but you can improve the quality of life. That's where a rehab intervention team is very helpful, with speech language pathologists, occupational and physical therapists. They can help improve the quality of life for this person. SLPs mainly aid in helping the person maintain communication, and oftentimes if it's a very severe case of Huntington's disease, they're going to recommend augmentative or alternative communication. They're also going to help aid in proper swallowing to prevent aspiration. As mentioned before, Huntington's disease has a very progressive nature, and so it starts with those pre-symptomatic brain functions and the degeneration of the basal ganglia continues, and so the symptoms of the dysarthria, chorea, dysphagia, everything is going to progress, in which they're going to need more assistance in their daily life and their daily tasks. Dementia, loss of voluntary movement, and loss of functional independence also become present, and death can occur at any time throughout the course of the progression. Usually 15 to 30 years after onset is when we see death occurring for these patients. I hope you found this PowerPoint useful. Thank you so much.